everyone. Thank you for coming and welcome to my talk, Webpack, It's Not Magic. I know it's been a long day here and you guys have seen a lot of cool talks, so thank you for still being here, and I hope that you guys don't fall asleep. The slides are here on the link shown on the screen in case you want to follow along or take a look at them later, and you can tweet at me at Naomi Codes later to tell me what you hated and what I got wrong. So let's get started. Who am I? My name is Naomi Jacobs. I'm a full-stack software engineer at MavenLink. I've been there almost a year. We make resource planning and project management software. We're here in San Francisco. We have a huge focus on pair programming and test-driven development. I love our culture. It's really fun, and yes, we are absolutely hiring, so please come up and say hi to me at the end if you're interested, and just come up and say hi anyway, even if you're not looking for a job. Currently, I'm working on our resource planning team. It's tons of fun, and our stack is Rails on the back end and React on the front end. We also use Webpack, which is what I'm here to talk to you about today. So let's get started with that. Cool, so why am I talking to you about Webpack? Well, it's a tool for web developers that is, one, very popular, and two, not very well explained. How popular? Well, here we've got downloads per week from NPM for Gulp, Grunt, Browserify, and Webpack from 2014 until January this year. And Webpack is the red line, which might be a little hard to see, but it starts out at the bottom and gets pretty high up. So the first stable version of Webpack was released in early 2014, and now it has over 1 million downloads a week, which is pretty crazy. As far as I can tell, that means that there are a lot of people using Webpack, and as far as I can also tell, a lot of people who are confused about using Webpack. And if you're wondering what that dip is all the way at the end, that's the winter holidays. Okay, so how did I learn Webpack? Well, I had used Webpack for some side projects, and when I tried to learn it, I thought its documentation and its API were really confusing. I wasn't really sure what I was doing, and it kind of felt like I was mostly copy-pasting other people's config files from Stack Overflow into mine and just sort of trying to, hitting play until it worked. Has anyone else had a similar experience with Webpack? Cool, I'm really glad to see that. I thought it was really confusing, and I put Webpack away, and I kind of forgot about it. But then my company, MavenLink, started using Webpack when we switched from Backbone to React. And so I suddenly had to figure out what was going on. And I realized that learning how to use a tool is a lot harder when you don't know how it works. So I started trying to figure out, okay, what is Webpack doing under the hood? How does it work? And I found a ton of stuff on how to set up my config file, saying here's how you use Webpack. But I didn't really find much on what it was actually doing under the hood. So I started doing some research, and today I want to share with you what I've learned. And the reason I want to do this is because we're better and happier developers when we understand our tools. So the goal here today is going to be to demystify Webpack and try to figure out what it's doing when it creates an asset. And I think that will make it easier for you to understand what's going on when you're debugging or trying to figure out why a build failed, and it's going to lay the foundation for you to be able to understand sort of all of the fancier features that Webpack has. And so what I'm going to be presenting is, of course, a simplified version of what Webpack actually does, but the goal is for you guys to come away with like a solid mental model of what's going on so that you have an idea of where to start and where to look the next time you run into problems. Cool. So today we're going to answer 3 questions. What is Webpack? What problems does it solve? And how does it work? Let's start out with what it is. So as Webpack describes itself, it is a module bundler with dependencies that emits static assets representing those modules. When I first heard that description, I didn't really know what it meant. And the way that I like to think of it is that it takes stuff that's nice for you to write and turns it into stuff that is nice for your browser to read. So what does that mean? Well, what's nice for you to write means that it's easy for humans to read. It has white space, it has formatting, it has readable variable names. It means that we have logically separated our code into multiple files. And it might mean that it's in a language that our browsers don't understand. It could be in ES6, or it could be in CoffeeScript or TypeScript, ClojureScript, whatever you want. But what's nice for your browser to read is ES5. It's also nice to have fewer requests, which is great for bad internet connections, and it's good to have smaller responses, right? Your browser doesn't care about your white space. Your browser doesn't care about having readable variable names. And so, as we're going to see, Webpack is going to help us do these transformations. So that's what Webpack is. Let's talk about what problems Webpack is going to solve for us. So the first problem I want to talk about is namespacing. Right? In JavaScript, variables that are declared outside of functions are global, and that means that it's really easy for a global namespace to get cluttered, and that can make it difficult for us to keep a good separation of concerns. The second problem is that files need a lot of work before they can go to the client, right? We have to turn it into the stuff that's nice for us to write, into the stuff that's nice for our browser to read. We need transpiling, we need uglification, we need minification. And the third problem, the one that I think is maybe the most important, is how to send the code how to send our code to the browser efficiently. And I mean that sort of in two ways, efficiently, both for the browser and for us as developers. If we had one script tag per every file in our code base, right, that would be insane. First of all, it's crazy slow, and second of all, it's really hard to manage our order dependency. We as the developers would have to be responsible for knowing, okay, well, this file needs this other file to work, so this file has to be requested before that, and it has to get back before we can use the other one. And it would be great if we just didn't have to worry about that at all. And I want to note that Webpack didn't solve these problems first. Gulp and Grunt and Browserify and other similar tools have been helping us solve similar problems for a long time, and I'm not bashing them at all. They're great. But Webpack sort of does it all in one go. I think it does it a little more elegantly, and its implementation, I think, is simple to understand. And as you're going to see, an entire Webpack-built asset is going to fit on one slide later on, and I think that's really cool. Okay, so now we can get to the fun stuff, which is how does Webpack actually work? How does it do its magic? Well, before we get started, I want to sort of clear something up and talk about how I assumed Webpack worked before I started doing my research. So I figured, okay, I have a bunch of files, and those files have dependencies. So our orange file depends on our yellow file, and our purple file depends on our orange and green files, and so on and so on. And as far as I knew, the Webpack, sort of wizard just kind of like smushed them all together, and out popped a plain JavaScript file. And I didn't really know how it did that. And if you had asked me, like, what do you think is going on under the hood, I would have guessed, like, well, I bet that Webpack's doing some sort of crazy dependency calculations to figure out what order all of the files need to be in, and then they're like concatenating them all together. And that's not crazy. There are other tools that do things that are similar to that. And it turns out that that's totally wrong. That's not what Webpack does at all. So if you're thinking that, I just want you to throw it out so that we can talk about how Webpack is actually putting things together. Cool. Is everyone with me so far? Yeah? Okay, good. So to start, Webpack is going to take the path to a single starting file. That's going to be your entry file. And it's going to be kind of the top of your app, the thing that's going to kick everything else off. And based on that starting file, it's going to build an asset for you in what we're going to think of as 4 steps. So that's going to be finding dependent files, applying loaders, implementing the module system, and then creating the final asset. And if you don't know what those are, don't worry, we're going to go over them right now. So let's talk about finding dependent files. So Webpack is going to keep track of all of the files that we need for our asset in a big array. Pretty simple. We're going to start at the entry file, and we're going to put that entry file in the first index in our array. Then we're going to look for dependency declarations in that file. Those are going to look like requires or imports. Webpack can deal with a bunch of different module systems. It can do AMD or CommonJS or ES6 modules, and we're going to talk about that later. And for each dependency that we find in that entry file, we are going to validate the path to make sure that it leads to an actual existing file, like that the file is where we say it is, that we installed it from NPM successfully. And if it leads to a valid path, we're just going to add it to the array. And we'll recursively do that through all of the files that we have so that eventually our array has all of the files in our dependency tree. And remember the array, it's going to be important later. Cool. Next, we are going to apply our loaders. You guys may have seen loaders in your Webpack config files. You guys might have downloaded loaders. If you don't know what a loader is, it's super simple. It's just a function that takes in source code, makes changes, and returns the new code. That's it. This is the JSON loader. Loaders can be really complex, but they can also be this simple. Loaders come from NPM. Anybody can write a loader. You can write a loader. Webpack has written a bunch of loaders. And the way that we use them is we tell Webpack, hey, apply this loader to these files that I care about. And we tell it to do that in the config file. And you can do that selectively with regex. So at MavenLink, we have a Rails backend, and we used to work in CoffeeScript. And so we have a lot of coffee files, but we also have a lot of plain JavaScript files. We don't want to waste time applying our CoffeeScript loader to our plain JavaScript files. So we tell Webpack, hey, only apply the coffee loader to the files that end in .coffee. And that way we can sort of get selective behavior so that we can save time. And we can chain those loaders together in whatever order we want. And so the loaders are how we achieve those transformations that we were talking about before. You can have a loader that does transpiling. You can have a loader that does uglifying. You can have a loader that does minifying, so on. You can also have loaders that do cool stuff like adding in your polyfills. So if you see like, hey, I see you're using a new class that exists in like ES6, but not in ES5, like if I see that you're doing that, I will go add that code to the window for you so that that's available. Cool. And so next we have to talk about implementing the module system. But to do that, we're going to have to take a little bit of a detour to talk about CommonJS. So as I said before, Webpack supports multiple module systems, but we're going to talk about CommonJS specifically to get an idea of how they all work. And the other ones have different syntax, but they work pretty similarly under the hood. The concepts are all the same. So what is CommonJS? I like to think of CommonJS as a system of writing JavaScript that allows files to declare dependencies on each other by importing and exporting modules from those files. In this system, we have one file per module, so if you hear me say file or module, they're pretty much interchangeable for the purposes of this talk. And so we import modules by requiring them, either by name or by path, and we export modules by assigning them to an object called module.exports. I'm sure a bunch of you have done that when you're writing JavaScript code, but you'll notice that you never had to define module, right? There's no place where you wrote var module equals a thing that has a property called exports. We just assume that it's going to be available to us, and we use it to export things. And the important thing to understand is that CommonJS is not a library, it's a standard. So we don't import CommonJS code. It's a set of rules that says like, hey, if you write your code this way, things are going to work the way that you expect. And so we write our code following the CommonJS system, and Webpack is what makes the system work by implementing that standard. Cool. So how does Webpack implement that module system? I think it's easier to go through this with a bit of an example. So can you guys read the code that's on there? Yeah? Okay, cool. So we're going to start out with an example. Let's say we have two modules, square and hypotenuse. Hypotenuse is going to be our entry file, and it's dependent on square. So in order to implement our module system, Webpack has to do two things. First, it has to wrap each file in a function. And so it's going to pass two arguments into that function. Those arguments are going to be module and a function called Webpack require that Webpack's going to define and that we're going to talk about later. Next, we have to go back to that array of modules that Webpack was building up. We know that our entry file is always at index 0, but the other files can kind of be in whatever order. We don't really care. It doesn't matter. The second step to implementing the module system is to replace all of our require calls with an invocation of Webpack require, where we pass in the index of the module that we want in our array. And so Webpack's going to go through the files and replace all instances of require with Webpack require with the right index in there. So as a bit of a bonus, you might have been thinking, like, hey, replacing require statements with different require statements kind of sounds like taking in source code, making changes, and returning new code. And you also might have noticed that wrapping each file in a function also sounds like taking in source code, making changes, and returning new code. So if you're thinking that those processes could be implemented as loaders, you are absolutely correct. And it turns out that Webpack does a lot of its internal stuff with internal loaders. And so what that means is that implementing the module system isn't really a separate step. It's sort of a sub-step of applying loaders. So applying loaders is applying the user-specified loaders, the stuff that we want, and then also implementing the module system with its own set of loaders. Cool. So how does this all fit together? Let's talk about how Webpack actually makes the final asset that we're talking about that you can send to your browser. What does our final asset need? Well, it has to have all of our code, right? We definitely want that. It has to have our entry file and then any code that it depends on. But it also has to have that Webpack require function that we talked about so that it can actually be used. And then it has to put it all together, make sure it works, and sort of kick it off. So we're actually going to write an asset that is really similar to what Webpack might write on the screen right now. So we're going to start out with a function that accepts an array of modules as an argument. So an array of modules exactly like the one that Webpack has been building up. And we're going to wrap it in parentheses, and we're going to immediately invoke it with that array of modules that we've been talking about. If you're not familiar with this pattern, it's called an IFI, or an immediately invoked function expression, and it just means that the function gets used immediately after it's defined. So then inside of our main function is where we're going to define Webpack require. And this is kind of the crux of it all. This is going to be the function that allows modules to talk to each other so that when one module says, like, hey, I need this module over there, Webpack require is going to say, oh, I know where that is. Like, let me go and get that for you. So inside of Webpack require, we're going to actually make the module object. It's just a plain JavaScript object. And it's got some other stuff on it that that we don't need to worry about right now, but the important thing is that it has a key called exports, which is also an empty object. And we're going to do this every time we want to get an export from a file. So this module object will only have the exports of a single file. Next, we're going to grab the file that we need. And we're going to know where it is because the index of where that module is going to be the argument that gets passed into Webpack require. So what you have to remember is that these files are all functions now, right? We wrapped them in a function. And we passed in module and Webpack require. So now if we have our file, we can execute it and pass in the module object that we just made and the Webpack require function. And so this is where that comes from. That's why we can use module.exports and just assume that it's there because it will be there. Webpack puts it there for us. And when we invoke this function, it's going to execute all of the code in that file. And when that happens, we're going to get any of the side effects that we want, right? We're going to get appending to the DOM. We're going to get logging to the console. Anything like that is going to happen. It's also going to require other modules, and then we're going to use Webpack require to get those modules recursively, so on until all of our code is finished executing. But what's also going to happen is that any file can attach stuff to the exports property on module.exports, and if it does, we'll be able to grab it and return that exports object because we still retain access to it in this context, which is what we do now. So we execute the file, and then we just return module.exports. So whatever module called Webpack require in the first place now gets the exports from the other file. Cool. And once we've defined Webpack require, we're going to kick off the whole thing by invoking Webpack require with index 0, right? Because our index file, our entry file, is always at index 0, so we know which index to start off with. And that's going to kick off the whole chain of events, and all of our code will get executed. But we've got a bit of a problem here, right? What if two modules import the same module? Wouldn't we be evaluating the same code over and over and over again? Like, that seems really inefficient. Once we've evaluated it once and have its export, we don't really need to do that again. Webpack is smart enough to handle that, and it optimizes it for that by caching off all of the modules. So in our main function, we make a cache, and then inside of our Webpack require function, if we've already seen that module before, if we already have its export, we do an early return and just send it back to the module, and we only evaluate the code again if we haven't seen it before. And so if we haven't seen it before, we evaluate it, get its export, and we save it in our cache for the next time that it's requested. And that's kind of it. That's the whole thing on one screen, on one slide, which I think is pretty cool. But some of you guys might be like, that's a lot of text, and I really want to see an example. So we're going to build a repo kind of ourselves, and we're going to walk through the resulting asset together, sort of as the browser would see it, so we can sort of get a feel for how this actually works in real life. Cool. So let's work with an example repo of 3 files. Our first file has no dependencies, and it exports a function that returns a number square. This is our old friend square.js. We've seen square before. Our second file we've also seen before, hypotenuse.js, and hypotenuse imports square and exports a function that can give you the hypotenuse of a square given the other 2 sides. And the new one here is going to be our index file, our main file, which imports hypotenuse, and its entire goal in life is to log the hypotenuse of 3 and 4 to the console. Pretty simple, right? So let's pretend that we compiled this repo with Webpack, with index.js as our entry file, and let's walk through the code as the browser would see it. So here we're going to keep track of a couple of things. On the left, inside of this white box, we're going to have the entire code of our Webpack asset. I've taken away the caching for space, but you can just imagine that it's back there. And then on the right, we're going to keep track of some of the variables as we go along. So we're going to keep track of our output, and we're going to know that we have sort of succeeded when we see index.js log 5 to the console. And we're going to start off where we had already defined Webpack require, and we're going to start out when we actually invoke it for the first time. Cool. So when we invoke Webpack require with 0, we pop into a context of Webpack require, and I'm going to keep track of what index we're looking for and what the exports object currently is. So when we first start, our exports is an empty object, and we're looking for the exports for the module at index 0. So we grab the file, we grab the code at index 0, and we're going to execute the file. When we do that, we pop into our module at index 0, and we see that the first thing we do is require another module, right? var hypotenuse equals Webpack require at 1. Cool, let's do that. We're going to go back into Webpack require, and now we want the export for the module at index 1. So we make a new module, we get the code, we get the file at index 1, and we execute it. We go into hypotenuse.js, and again we see that the first thing that we're doing is using Webpack require again, right? var square equals Webpack require at 2. So we go back into there, and as you'll notice, we still have those other two. We still have the other 2 invocations of Webpack require in our call stack. We haven't finished with them yet. We're just doing this one on our way down. And we want to get the module at index 2. So we get the file, and we execute it. And finally, we end up in a file that isn't requiring something else, right? We end up at sort of one of the leaves of our tree. It doesn't have any other dependencies. So the only thing that Square does, it doesn't even return anything, right? It just says module.exports equals this function. And when we finish executing this file, We'll finish with Square.js, and we'll come back into our invocation of Webpack require that wanted, the one that wanted our module at index 2, and now its module.exports has the function from Square. We retained access to it through our context, and we can return that function, our Square function, back to hypotenuse. And so var Square equals Webpack require 2, now Square is the function that we need it to be. And we do the same thing here. We just attach a new function to module.exports. We end up in here, and now module.exports is, oh, sorry. Oh, no. Sorry, guys. Got a little too excited there. Cool, there we go. And we end up back here in the invocation that wanted hypotenuse.js. We now have hypotenuse. We pop back into index. We have hypotenuse because we have all the other ones, and now finally we can say we can log to the console the number that we wanted. So we got all of our code. Everything else, so we're sort of done, right? We saw the side effect that we wanted to. Webpack's going to keep going. It's going to continue finishing off its job, and it's going to eventually return the export of index.js, which won't be anything. And that's kind of it. So how did this solve our problems? Well, we had the problem of getting our code to the browser efficiently. Now we have a single script tag per entry file, and it manages all of our dependencies for us, which is great. That saves a ton of work for us as developers. We don't have to worry about the order. It also solves our global namespacing problem, right? Because we wrapped each file in its own function, all of those variables are now scoped to their own files, and they only expose what they put on the exports object. And what I think is pretty cool is that we can get something sort of similar to, we can sort of get module privacy in JavaScript now by just not exporting something. So we have a Rails backend, and in Ruby, you can declare certain methods on classes to be private so that other things can't use that. And we've never had that ability in JavaScript, and so you can get something similar where you can have control over what code you expose to other modules, and that lets you treat each file as a black box that has a defined API, and that can lead us to be able to do some really good code patterns and have some really nice separation of our code. And the last problem was that it was difficult to manage the transforms that we wanted. Now we tell Webpack to apply the loaders that we want to the files that we care about, and the browser ends up getting plain JavaScript that it can read, which I think is pretty cool. Thank you all for listening so much. I want to thank ForwardJS for planning everything today. Again, my name is Naomi Jacobs. I'm a software engineer at Mavenlink in San Francisco. We are hiring. You can reach me at Twitter or GitHub or email. So please reach out to me and let me know what you learn. Okay, thank you all so much for coming.